around the edge of the pizza. And what I'm going to do when I find the arc length is I might only be finding that distance on one piece or two pieces or three pieces. So instead of finding the entire distance around or the entire crust of the pizza, I'm only going to find a fraction of it. And so we have two different formulas there. We have formulas for when theta is in radians and when theta is in degrees. And so if you look at each of those formulas, they're noticeably different. Okay, and so once you get that down, we're going to go ahead and talk about the degrees formula. And also, I would encourage you not to write down that problem because I'm going to show you a more abbreviated way to write that, which is, once again, some of those note-taking techniques that you're going to learn for the future.
That problem?
Okay, yeah. The one underneath the dashed lines. So, first of all, okay. Not working.
Degrees is way harder.
Okay, so first of all, we're going to go ahead and, there we go. We're going to go ahead and look at that formula for theta in terms of degrees. So I want you to look at that formula and tell me, where does that look familiar? From what? Specifically what part?
The last part that we learned from yesterday.
I don't know.
Yeah. 2 pi r.
No.
Where is that
That's
familiar? That's the circumference of a circle, so that's the crust of the pizza. That's the distance all the way around. And so what we're doing here when we say theta over 360 is we're finding what fraction of the circle are we looking at. So if it's 180 degrees, 180 divided by 360 is actually 1/2. So you're taking 1/2 of the circumference.
That's it.
Okay, and so that's really what that formula is stating. It's nothing new. And so if you look at the very first problem we're going to look at, it says find the length of the intercepted arc in each circle with a radius of 5 centimeters and a central angle of pi over 4. So if I were you and writing this down, this is what I put. R equals 5 centimeters. Okay. And then I would put theta equals pi over 4. And that's it. And then now we're going to solve the problem. So see, what we've done is we've cut that whole problem down to r equals 5 centimeters, theta equals pi over 4. And so the formula we're going to use is s equals r times theta. So in this case, it's going to be s equals 5 times pi over 4. So when I take 5 times pi over 4, I get 5 pi over 4. Now, what would my label be?
Centimeters.
Centimeters, very good. Oops, that's supposed to be centimeters, by the way. It's supposed to be C. Now, just for kicks and giggles, let's go ahead and, on your graphing calculator, I want you to go ahead and calculate for me what 5 pi over 4 is. The pi button is located on the right side of your calculator.
Sure.
It's located right above the division sign in blue.
3.93.
What does it come out to be?
3.93.
I still can't hear you.
3.93.
3.93? 3.93 centimeters. So if we wanted to find the decimal equivalent, that's what it would be. Okay, let's look at another problem. Find the length of the intercepted arc in a circle with radius equals 2 inches and central angle 60 degrees. So once again, instead of writing all that, a good thing to write would be r equals 2 inches, theta equals 60 degrees. Okay. So s equals theta, which in this case is 60, divided by 360, times 2, there we go, pi r. So really, what fraction of the circle are we looking at? The radius is 2. Right. I'm looking at a fractional part of the circle as being 1/6. Okay, and so I'm going to take that times what? 4 pi. So now let's calculate that. What is 1/6 times 4 pi? Leave it in pi first. 2 pi over 2 pi over, I don't know, 2 pi over 3. Thank you. Where does it come 4 2 times, folks. 2 goes into 6 3 times. 2 pi over 3 label will be inches. Now, for kicks
And giggles.
and giggles, what is the decimal approximation? 2 point what? 09.
Pi button.
We don't have to do that actually.
Okay,
Threatening
the
the
reason
clear button.
why I'm having you do decimal equivalents is one, just getting used to using the pi button on your calculator since you haven't had much practice doing that. And two, if we were to look at an application-based problem, which might be coming up in the future, you can actually do that. So let's go ahead and look at the next thing. Okay, we got some more notes here. And that is area of a sector. Now real quick, I have S here. I'm going to change that S here to area. So let's change that S here to A. There we go. I was quickly doing these equations last night as I was sitting, taking tickets. So anyway, I kind of got going with the S's and yeah. So anyway, now we've got A's, because that means area. Okay, so let's go ahead and look at the next one. Find the length of the intercepted arc. Oh, good grief, I made 2 mistakes.
Oh my gosh.
Find the area of the intercepted arc in each circle with a radius of 5 centimeters and central angle pi over 4. Now, before we even start that, I want you to go back and look at the formulas. Okay, what do you notice?
Pi r squared.
Ah, pi r squared. And what is that? The area of a circle. So really, once again, all we're doing is we're finding what fraction the sector is of the circle, and then we're taking that times pi r squared. So let's go ahead and look at the one below. This one, r equals 5 centimeters, theta equals pi over 4. So my area is going to equal 1/2 times r squared, we got the little squared there, times theta. Woo. 1/2 r squared times theta. So let's calculate the top. 1 times 5 squared times pi. 25 pi. On the bottom I've got 2 times 4, which is 8. Label is cm. Centimeters. Okay, decimal. What do we got?
9.82.
Somebody else get a second?
9.82.
Okay, I think that's a confirmation. It's a 9.82. So that's what the area of that sector would be. Okay, there we go. Find the area of the sector of a circle with given central angle and radius. So area equals 1/2 times 1.5 squared times 3 pi over 4. Okay, so all we need to do now is calculate that. Now this one, I will tell you, right now has a mixture of decimals and fractions. Since you're given decimals in the problem, you may answer decimals. So in fact, that's what we're going to do here. Okay, this one actually comes out to be 2.25. So what you're going to do is take 1/2 times 2.25 times, what's that? 0.75 times pi. Okay, so once again, 1/2 or 0.5 times 2.25 times 0.75 times pi. And what does that come out to be? 2.65. Do I have a second?
Yep.
Feet, what's my label?
Squared.
Feet squared. Did I square the one before?
No.
Okay, you need to go back and square it. Sorry, this
Pi,
one.
pi.
Okay? No, there's no pi here because you multiplied it out.
Because it's a decimal?
Yep.
What?
So when you guys took this times pi, didn't you?
Yeah. Yep.
So you guys took exactly what you have here.
Yeah.
So you've multiplied everything out.
Okay.
Okay, this is one in which you're probably not going to be able to get an exact answer of pi. The only way you could get an exact answer of pi is if you would use a radius of 3/2. Okay, because that's what 1.5 is equivalent to. And so what you could do is use 3/2 and that you could get a fractional value there. Okay, but here we've actually multiplied pi out in our answer.
Okay.
So let's look at another one. Find the area of a sector of a circle with given central angle and radius. So this one's different. How's it different? Theta's in degrees. Good. So now we need to find our fraction. So I'm going to go ahead and write our fraction as 50/360. And I'm going to take that times the area of a circle. So times pi
2 pi.
times r squared. So now let's go ahead and multiply out. First of all, those are gone. And I really get 5/36 times pi times 36. Oh, isn't that nice?
Oh.
That is just so nice. What happens to your 36s? They're gone. And I'm left with 5 pi, and my label is meters squared. Make sure you get this squared down.
So why don't you
no.
multiply the pi out?
Okay, because the reason why we did in the problem before was because it was decimals. You can't mix a decimal and pi. Okay, so I don't want to see like 5.32 pi. Okay, this one can be exactly written in terms of pi, so this one needs 2.
Okay.
But this one before, if I was going to give an exact answer of pi, would be, what's that going to be? 1.125 times 3 divided by 4. Okay. All right, so now this is what you need to add to your assignment. 27 through 32, all 43 through 48, all 58 through 61. Now, I believe you've already done the evens in this first area here. I think you've already done 28, 30, 32, 27, 26. Okay, but there you go. That is your assignment then. Now, on Monday, a little bit about what you're going to be doing. On Monday, you're going to be having a quiz and a worksheet over degrees and radians again. On Tuesday, you're going to have another worksheet on trig applications. It's going to be dealing with right triangles. It's going to be a little longer. You're going to have to draw right triangles, solve them. It's going to be word problems. Okay, on Wednesday, we're going to be going on with section 4.3. Okay, so that's a little bit planned. Those of you that are going to be gone Wednesday, you'll need to probably watch the video. Go over